All right, welcome everybody. This is 6.1. This whole section, 6.1, 6.2, we're going to be talking about law of sines, law of cosines, and in 6.1 we are going to focus on law of sines. Just like normal, we have a couple review questions. Go ahead and pause and work those out. Should just take you a moment or two. All right, we're back. I listed all of the answers here. So one form, it could have been either of the three, or one of the three, excuse me. And in the second one, they're asking you if sine of x is equal to 3/5 and x is in quadrant 1, find sine of 2x. Well, this becomes a 3, 4, 5 triangle. Sine x is really 2 sine x cosine x. So that is 2 times 3/5 times 4/5, which equals 24 over 25. Now, today's goal, we want to solve a triangle by using the law of sines when given two angles and one side. So consider the following right triangle and find all the missing sides. So they're telling us that this is a right triangle. So first thing, just like with most of the work that we do, is you want to draw a picture. Make sure you see what it is you're doing. They said it is a right triangle. They're giving us the angle measure for A, so I'm going to call this A up here. So this one right here is 42 degrees. And the side A, which would be across from that, so we're talking A down here, this is 9.2. And so they want us to solve. Now, when they say find all the missing sides, then they want us to find this side right here, so I'll call this C, and this side right here, which I'll call B. That means this is big B, this is angle C. And now I just want to make sure I understand that to solve here, I'm just going to solve the whole thing because it just kind of makes more sense to do that. So looking at this, the things that are missing, well, we're missing angle B, we're missing side B, and we're missing side C. So these are going to be the sides that we're looking for. So how do we do that? Well, if we think about angle B, we already know that C is 90, A is 42, so B, that must be 90 minus 42, which B is going to be 48 degrees. So now I know that particular one. Then side lengths, well now if I just start from B and solve this out, we're going to say that we're looking for the side opposite, and I know the side adjacent. So this would be a tangent situation. Tangent 42 degrees is equal to the opposite, which is B over the adjacent, which is 9.2. And now, solving this out, B is going to be 9.2 times tangent of 42 degrees. And then we're going to work that out. Now keep in mind this, I'm going to erase my equal signs because we're going to have to round. So these are both going to be approximations. And this would be approximately written out to one decimal place, 10.2. So you're plugging that in your calculator. Make sure you are in degree mode when you do that because you're given degrees. So this is approximately 10.2. And then the last part of this, we're looking for length C in this problem. Well, length C, if I figure that I could still go from angle B here to find C, instead of using a tangent here, we're going to use an adjacent and a hypotenuse. So that would be a cosine. So we can say cosine of 48 degrees is equal to the side adjacent, which is 9.2, over C. Now, keep in mind that I don't have to go from B. I could go from angle A. I do know the opposite side, and I do then would just find the C, but we'd be using a sine function instead of a cosine. In this particular problem, we're going to move C to the right, so we're going to multiply both sides by C and then divide by cosine of 48 degrees. So we're going to have 9.2 divided by the cosine of 48 degrees. You plug that in your calculator as well, and you should end up getting an answer that is approximately 13.8. Now, keep in mind, I'm solving this, but because these are going to be rounded off answers, you're going to have approximations. So hopefully this makes sense. Hopefully this is coming back from geometry. This is basically what you would do in geometry to solve a right triangle. So this was how you solve a right triangle, but what happens if you don't get a right triangle, a non-right triangle? And that's what we're going to look at next. We're going to talk about this idea of solving a non-right triangle. So consider the non-right triangle. Then solve the triangle if A is equal to 46 degrees, B is equal to 23 degrees, and side B is equal to 5. So first things first, draw a picture. This is saying a non-right. So I'm going to just draw this, but as long as I don't put the, angle measure up there at the top, it's not going to make any difference. Here's A. I'm going to make this A, B, and C. You can use any orientation that you want. Just keep in mind that the triangle might be a little different, but I usually try to, if they're giving me an angle measure, so one or the other of these, I try to put them in the lower left. It just makes more sense to me, but that's not necessarily something you need to do. They're saying that this angle is 46 degrees. They're saying that this angle is 23 degrees. And they're saying this length is 5. So they want us to solve the triangle. Well, the obvious things we need to find little c, so side length C, and we need to find side length A. How do we go about that? Well, same way we started the last problem. That should really be no different here. We have 3 things we need to find. Angle C, which should be easy to find, side A, and side C. Remember, these are going to be approximations. This will be an equal because we pretty much know that's going to be the case. How do we find angle C? Well, it's 180 degrees, and we're going to subtract the addition of 46 degrees plus 23 degrees. And we're going to get an answer here of 111 degrees. So now I'm looking at my picture, and I'm kind of noticing here that C is not really 111 degrees if you're looking at it. But as long as I say it's 111 degrees, that should be no big deal. So we've solved the angle problem. Now we need to solve A and C. But here is where the problem gets a little bit different, because remember, we can use tangent, we can use cosine or sine in right triangles, but this is not a right triangle, which means in order to make this work, we're going to need to create a right triangle of some sort, and that's where this idea comes into play. We are going to break this into 2 pieces so that we have a right angle and obviously a right angle. And now I have 2 triangles that are both right triangles. Now keep in mind, I should be able to find A fairly easily. C might be a little more difficult because now I've got 2 parts here, but I just really need to understand that even though I have these 2 parts, the idea of how to find the length should still be the same. This one we're just going to call X, and we'll call this one Y. And now I just need to solve those things based on X and Y, then I can add X and Y together, and I get my answer, whatever that is. So how do we go about this? Well, I have these 2, and what I'm really looking for now is I have to find the height. Once I find the height, everything else falls into place, but you first got to find it. And keep in mind, I have a side length over here. B is equal to A. Or sorry, B is equal to 5. I don't have a side length for the other one. So I'm going to start on the left triangle, and I'm going to work my way through it. First thing I need to find is H, because I need this in order to make anything make sense here. So remember, if I know an angle measure, I got to have the side opposite of it most of the time to solve something. So let's keep that in mind. First thing I'm going to do, if I start from this angle measure of 46, then it's opposite over hypotenuse. So this would be sine of 46 degrees is equal to h over 5, which means that h is going to equal 5 times sine of 46 degrees. And then we're going to plug that into our calculator. And when you do, you should get an answer that is approximately 3.597. Now, it's not telling us what to round to, so if it's not saying what to round to, the minimum you should be rounding to is 1 decimal place. So just make sure that if you're going to round to 1 decimal place, you have 2 more decimal places to make sure that you don't lose precision when you do this. So that's why I'm going to be using this. Keep in mind, if one of the side lengths given to you is 2 decimal places, then you should be rounding all of your answers to 2 decimal places. That's the way it should be working. Now, once I have my h, what is it I need to find? Well, if I know then that this is 3.597, I should be able to find x. No big deal. And if I know that I'm using this number in the other triangle on the right-hand side, well, then I should be able to find a and y. Those should be all the things that I should be able to find. So let's go down here and we're going to work on that. First things first, sine of 23 degrees is going to equal 3.597 over a. So I'm going to look for a here. I'm going to multiply both sides by a and then divide by sine of 23. So a is going to equal 3.597, and I'm going to divide that by sine of 43 degrees, but 23 degrees. When you do this and round off, in this one I'm just rounding to 1 decimal place, you plug it in your calculator, you should get an answer that is 9.2. That should be the answer for that one. Now, how do we find x and y? Because those are the other two we need so that we can do that. Well, if we think about it, c is going to equal x plus y. That's what I'm looking for. And I need to set up each one of them, x and y. And you can do this in numerous ways. If we start at 46 degrees, we could use the side opposite and the side adjacent. That would be tangent. We could use the side adjacent and the hypotenuse. I'm going to use those simply for the fact that whenever they give you a number, you should do your best to use the number, not the rounded answer. Just easier that way. So off here to the right, I'm going to look for that first one. It's going to be, I'm going to use x and this one, so it's cosine of 46 degrees is equal to the adjacent over the hypotenuse. So x is going to equal 5 cosine 46 degrees. Now, I'm not going to put that in. I'm just going to write it over here, 5 cosine 46 degrees. And I'm doing that because I know I'm going to add things, and I don't want to keep rounding and rounding and rounding. So when I do this in my calculator, I'm just going to do it all at once. It'll be a lot simpler. For the y value here, I don't have a choice of a whole number here. So I'm going to use the value of the height. So I'm going to be using the side opposite, the side adjacent. That is tangent. So tangent of 23 degrees is equal to the side opposite, 3.597, over the side adjacent, which is the y, which means y is going to equal 3.597, and I'm going to divide that by tangent of 23 degrees. So over here, 3.597 divided by the tangent of 23 degrees. I'm going to just put all that in so that I only have to do that once in my calculator and then round it off accordingly. In this case, once you've done that particular work, you should find that you have an answer that says 11.9. So, solved. I took a non-right triangle and I created a right triangle. That was the goal that we had in mind when we did this. Hopefully this makes sense. Remember, draw a picture, break things up accordingly. That's the key. Okay, so now what we're going to do is we're going to derive the right triangle, in particular the law of sines. That's our goal here in this particular problem. So what I'm going to do is I'm just going to start with that non-right triangle. Like I said, it doesn't have to be perfect. You don't have to draw it perfectly. Try to set them up the same way, but it just depends on what they're giving us. This one is C is equal to, this one is B is equal to, this one is A is equal to. So, just like with any non-right triangle, the first goal should be to create right triangles. Here's H. So, we're going to create a right triangle here, or two right triangles, and then we're going to set up a couple of proportions, and we're going to talk about how this works. First one we're going to set up, I'm going to start from A right here. And from A, I'm going to say the following, that sine of A is equal to the opposite, which is H, over B. That's my first one that I'm going to set up. The second one I'm going to set up is I'm going to go from B, and I'm going to say that sine of B is equal to H over A. Now, they both have the same thing in common here, which is a H. So I'm going to solve this one for H. H is equal to, sorry, let me go back up here. H is equal to, this is going to be B sine of A. And in the second one, I'm going to solve for H again. H is equal to A sine B. And now, since both of those have an H involved with them, I'm going to do the following. I'm going to say, if this thing will go, I'm going to set each one equal to its to the other. So B sine A is equal to A sine B. And then I'm going to divide. I'm going to divide both sides by B, little b, and both sides by little a. So I'm going to divide this side by B and this side by B. I'm going to divide this side by A and this side by A. Obviously on this side, the B's are going to cancel out. This side, the A's are going to cancel out. And we are left with something that says sine A over little a is equal to sine B over little b. And then the last part that we can talk about. Now, I set this triangle up in this particular manner with A and B at the bottom. But I could just have easily said C was at the bottom and B was at the top. Or A was at the top and C was at the bottom. The order here doesn't matter. What does matter is that hopefully we realize that if I had put C in a different place, we would end up with this thing as well. That sine of C will be over little c. This is what are known as the law of sines. These proportions they're going to hold in any triangle that we're talking about. Now, inversely, I'm putting sine of angle A over A. This would also have to be the case, that A over sine of A is going to equal B over sine B, which is equal to C over sine C. These are what we call the proportions for the law of sines, which is right here. So hopefully we understand that part of it. It says here that we're going to use the law of sines when you're given any three parts of a triangle. So here's the first one. Two angles and a side. Now, it's not saying the included side, just two angles and a side, which means angle, angle, side. If we know two angles, then we really know three, so it won't matter much which side is given in this problem. So hopefully we understand that, whether it's the included or the excluded, doesn't make any difference. The other one that they're going to talk about, one angle and two sides. Well, now we'd be talking about one angle and two sides we would have, depending on where we are here, SAS would be something that we might consider here. For example, if we're given angle A, well then we would need, the two sides would either be A and B or A and C. Hopefully that makes sense. We need the side opposite and then one of the other sides. For angle B, we would need AB or BC because we need the side that is opposite of the angle. And then for the last one here, it would be AC or BC. Those would be the sides. So here they're saying we must be given a side that is opposite one of the angles. This is what is known as SSA in geometry. And you guys talked about SSA in geometry and the fact that if you turn those around, it's going to say ass, and oh boy, that's exciting. And usually your teacher's going to say, you know, don't use this one because it's going to make an ass out of you and me. Well, that's basically what they are saying. But here we're going to talk about how you actually could solve something like that. Also, up here, I did say angle, angle, side. We could also say angle, side, angle, because even if we say it like that, you still could find the third angle, which would mean you would have an angle and a side opposite. So keep that one in mind as well. If we're given two sides and the middle angle, SAS, we cannot use the law of sines, and we have the law of cosines for that. So we'll talk about that. So easiest way to understand these things, do a problem. First things first, they're giving you a triangle. So I'm just going to make my triangle. It's giving me the angle A and the side opposite of that. So I'll say this is A. They're giving me angle B. I'll put C up here. Angle A is 57 degrees. Side A is 2.34. And angle B is 65.3 degrees. So what is it that we need to do here? We're trying to solve the three parts. We need to find little c. Let me make that a little better. Little c and little b. Those are the two, plus we need angle c. Angle c shouldn't be difficult to see now as we go through these. So let's just start with that one. Angle c. Angle c is going to equal 180 minus 57 degrees plus 65.5 degrees, which is going to equal, and in this one, angle C is 57.7 degrees. So here's our first answer. Then we also need to find little b, and that will be an approximation, and little c, also approximation. I'm going to do the work underneath here for these two last final answers. So for length b, one thing to always keep in mind, we do need our h. That has to be something we find in every equation here. So to find h, we can use we can only use the right-hand side since they gave us the little a here. So I'm going to start by saying I'm looking for this one, the h. So opposite over hypotenuse. So sine of 65.5 degrees is equal to, this is going to be h over 2.34. Well, that means then in this one, h is going to equal 2.34 times sine of 65.5 degrees. So what is that going to tell us? Well, that means then that our our height for this particular one is going to be approximately 2.1259, approximately. Now, if I know that length, now it's just a question of solving this thing out. So first things first, and we can use this law that we had before, because we don't necessarily need to solve out a bunch of things. We can find C a lot easier. We don't have to do this in parts. So for the first one, if we think about our triangles here, we're going to have the following. Now, hopefully what you guys are seeing is that you can use the height, you can solve this thing out, but we could just use the law of sines and the law of cosines, or sorry, the law of sines for each of these. Okay, because what it's saying is that sine of A, so we have our angle A and the side opposite. We have our angle B, but we're missing the side opposite. But we can set up the actual law of sines to solve this. It would be sine of 57 degrees over the length, 2.34, is supposed to equal the sine of angle B, 65.5 degrees, over B. Now, I just cross multiply and divide. That's kind of the idea here. So when you cross multiply and divide, you're going to get, I'm going to multiply both sides by B, and then I'm going to invert the other fraction and multiply it to the other side. Hopefully that makes sense to you guys. So B here is going to equal, I'm going to invert this one. So 2.34 sine of 65.5 degrees, all of that is over sine of 57 degrees. In this particular case, we're going to put this all in our calculator and work it out. When we work it out, we're going to round off to 2 decimal places. This is approximately 2.53. And then we're going to do the same thing for C. I know what angle measure C is. I know that I need the side across, and I have A and the side across. So I'm going to use the same one I did in the first problem here. I'm going to use sine of 57 degrees over 2.34, and it's okay if you use it twice, doesn't matter, is equal to, now I'm going to use C, the sine of what C was, which was 57.7 degrees, over little c. So we're going to do the same thing I just did, cross multiply and divide, but basically you are going to multiply both sides by c and then invert the other one and multiply it across. 2.34, we're going to multiply that by sine of 57.7 degrees, and we're going to divide that by sine of 57 degrees. When you do this, put it in your calculator, you're going to round it off. You're going to get an answer approximately 2.36. And that would be solving out your triangle. Now, I did calculate h, but hopefully you see that we don't need h if we're using the law of sines. That's a lot simpler. We don't have to go through all of those steps to get there. Let's take a look at this next one. I want you to try the next one. I'm going to pause the video and then I'm going to come back. So pause your video and go forward. Okay, hopefully that you did get these particular answers. B was 88 degrees. Then A ended up being 13.1 and C is equal to 3.2. Now keeping in mind, if we think about it, 88 degrees, that's the biggest angle, so it should have the longest side across from it, and that is the case, as this one is 13.1, this one is 3.2. Hopefully that makes sense. So let's move on to this next part. This one says find the area of the triangle. So normally, just like with anything, you should be thinking about drawing a picture so you understand what it is you're trying to accomplish. They're giving us A and angle A, so A, B, and side of this one, 9.28, and this is in centimeters. This is 27 degrees. This one is 72 degrees. And now they want us to find this. Now I'm putting this in here because I know that the area of a triangle is equal to 1/2 the base times the height. Or for this particular problem, 1/2, here's C up here, 1/2 of the length of C times the H. That's really what this one is. So I need to find the height, and then I need to find the base length here of little c. So we're going to do that by finding the height based on the side lengths they give us, or the side length they give us, and then we're going to find the base length, or c in this case, by using the law of sines. So first things first, h, well, I'm going to be using the angle measure of b here, so sine of b is equal to 72 degrees, and sorry, I don't want to say it like that, not sine b, but sine of 72 degrees is equal to the h over 9.28. So h is going to be 9.28, and it's going to be sine of 72 degrees. Now, we can solve this right now, or we can just plug it all into the equation when we're done, which is what I kind of like to do, so I only have to use my calculator once, and then I'm done with it. Let's take a look here. The law of sines. I need to find length C, so I need angle measure for C. So I'm going to go angle measure for C. Well, this is this is going to be 180 degrees minus 27 degrees plus 72 degrees. So angle C in this one is going to be 81 degrees. So now that I have my angle measure, I'm going to use my law of sines. To solve this, I'm going to use A and the length across from it. So sine of 27 degrees over the side opposite, 9.28, is got to equal, now I'm going to be using C, angle C was sine of 81 degrees over little c, because that's the length that I need. Rewriting it all, it's going to say little c is equal to 9.28 sine of 81 degrees, all of that is over sine of 27 degrees. And now I'm going to rewrite my equation. A is equal to 1/2 times c, little c. Well, little c is 9.28 sine of 81 degrees. All of that is over sine of 27 degrees. And I'm going to multiply that by the height, which was 9.28 sine 72 degrees. And I'm going to just use my calculator here and plug it all in so that you guys can see that it really doesn't matter at this point when you do this. Half. Well, half, another way of saying half is 0.5. So 0.5, and then I'm going to open a parenthesis, and then I'm going to just plug in what I know. Keep in mind, I don't necessarily need to use parentheses at the top or bottom here, because multiply is going to happen first and then followed by the division. If you're not comfortable with that, then use your parentheses, no big deal. So in the first one, 9.28 sine of 81 degrees, close that, and then I'm going to divide all of that by sine of 27 degrees, close that one, and then close it again because that's the end of that one. Then open up a new one, say 9.28 sine of 72 degrees. Close that, close the last one, hit enter, and you should end up with an answer that says this particular thing. So for here, my A in this one is equal to 89.09 centimeters squared. And it's an approximation, so not an equal sign. So hopefully you guys see that. I rounded it to 2 decimals because the original number was 2 decimals long. I didn't round anything off as I went. I just used the original values, and that's what you should be doing. Give this next one a try. So hopefully you worked it out. You came up with an answer that said 686.5 centimeters squared. This is basically how you would work these problems out. The last part of this, options for finding the area of a triangle. Couple things to point out. These are used in two situations. You're going to use Hero's formula when you have SSS, so all the side lengths are known. We can't really use that here because we don't know all the side lengths. We could find them all, but we just don't, they're not given. So it would be more work to find them all than to do what we just did. The other way of doing it is this idea right here, and this is when SAS is known. But we also don't know that one in this situation, side angle side. We could do it, I guess, looking at this, but it would just be, later on we're going to use these, and these will be important. So down here, just put a thing here and say, use later. We're not going to use those exactly right now, but we will be using them later. Also, under Hero's formula, this says square root. It means square root of all of this. So you need to extend that on your formula sheet. And then it says where S is this thing. You're going to take all the side lengths, add them together, and then take half of that. Like I said, these will come in handy a little bit later. Right now, focus on the other one. Sorry this one went so long. I know this one always goes long even in class. So thanks for hanging in there. We'll talk to you guys next class period. Bye.